Hi class, welcome to Material Science and Engineering 2010 Introduction to Material Science and Engineering, or if you're mechanical engineering or civil engineering students taking 2160 Elements of Material Science. These classes will be taught together, so you're in the right place if you found this video. In today's video, I'm just giving you a brief overview of the class because I'm going to have to miss the first 2 days of classes. I'm actually heavily involved in research, and one of the conferences in my field foolishly scheduled their big conference out of the country on the first 2-day classes, so I won't be able to be there. So we're going to make this video instead. I want to cover just some of the key points on the syllabus and describe some of my philosophy when it comes to this class so that you know what to expect for this semester. So I'm just going to kind of go through it. If you do have any questions, go ahead and start using Canvas in the discussion section or using Piazza, which I'll describe in a moment, to ask some of those questions and I'll respond to them. Or you can always email me, and my email is found, you can email me through Canvas, or my email will be found on the syllabus, which will be posted on Canvas, and I'll show you that in just a moment. So first off, when it comes to the book, what I'd really like to stress is that you shouldn't be spending a lot of money on this book. I sent an email out to people in the middle of the summer, so if you'd already enrolled in the class, you got that email. And what I'd like you to do is buy an old used copy of this book. The official class text is this 3rd edition. It's the one with the orange cover. It looks like this. So if you want the exact same book that I'll be using in case I assign a reading on a certain page number or something, that's the one you want. That said, the 2nd, the 3rd, and the 4th edition are all almost the exact same. In fact, the 9th edition isn't that much different. So I suggest that you buy a cheap copy. That said, if you want the exact same homework problems that I'll be assigning, you want this 3rd edition, which the bookstore will carry. That said, I will be posting the homework problems from all of the chapters from the 3rd edition as PDFs on the course website. So if you do buy the 2nd or 4th or whatever edition, make sure that you use the homework questions from the 3rd edition. I want to do this to save you guys some money, okay? All right, the course website will be on Canvas, right? So you'll be able to go to the Canvas website, and when you get there, right when you arrive, I think I have it set to land on the assignments that are available. So while that's pulling up, just realize that we use Canvas for frequent announcements. So I'll be posting reading assignments or additional information on things that we talked about in class, announcements about study guides for tests. All of that will happen in Canvas, so you're going to want to pay attention. If you want, you can update your profile to have a picture, and the TAs will start memorizing your names. I've actually got a cheat sheet of all your names, and I will have your names memorized for sure within the first week of class, hopefully by the first day that I get back. Now, something to realize is that the grades are reported on Canvas. So for example, we come over here, and if you click on grades, you'll be able to see your performance in the class. But just realize that because we're teaching multiple different sections all together, and you're all graded on slightly different things, that the grade weighting won't be accurate on Canvas. What do I mean? Well, for example, the Introduction to Material Science and Engineering students that are taking 2010, they also have to take a lab. And so that comes into their grading. Whereas the mechanical engineers don't have the lab, and so they have a slightly different grade weighting. So ignore the final weighting here, but this is a good way to see the raw grades on individual assignments and exams, things like that. Okay, now there's something called Piazza. You can click the link here, it'll take you right to it, or it's also found on the Canvas page. For example, if you come onto here to Canvas, and here on this left-hand side, there's this Piazza link. If you click that, I haven't tried this before. We're going to try it for the first time this year, but I hear great things about it. Essentially, this is a really responsive tool for answering and asking questions and having an in-class discussion on things. So we will give it a try this year. If you're stuck on a homework question and you can't make it to one of the TA hours, go ahead and post it on here. If you've got a question or if you need some additional clarification, try posting it on here. Make a new post. I will try and watch these really closely. My TAs will as well, and fellow students can give responses. So this is a way to manage content and discussion in these large class formats. Okay. The last website I'd like you to know, and I apologize, there's lots here. This is all links to all of these things are found in the course syllabus. Is Top Hat. We will be using Top Hat as a way to do active learning in this class, okay? So what this means is that we will have reading quizzes typically before class. These shouldn't be challenging. These should be relatively simple and just be a way to ensure that people are basically trying to do the reading. You'll be able to get your participation points. So in class, I expect you to actually come most of the time. If you miss a few days, it's not a big deal, but I expect you to be there most of the time participating. And so I'll be assigning participation points based off of in-class questions on things. Another really cool thing about this Top Hat website, I'm going to jump there real quick. Well, that's opening. We have these really helpful embedded videos that show worked example problems. And I've broken these down by chapter in the book. So there's this worked example problems folder. Okay, well, this is pulling up. I get lots and lots of requests for students. They find that while I'm lecturing in class, they'd like to see more worked examples. So that's what this is meant to be, and that's not opening for something. I'll come back to it. You'll be able to find lots of example problems that I've put on YouTube and then embedded in there so you can find them easily. All right, TA hours. First off, TA hours are going to be primarily for supplemental instruction, meaning if you went to class and you just didn't get a concept, I want TA hours to primarily be about providing that additional instruction. Now, homework can be part of that, but it should be primarily understanding concepts, and then it can be, checking to make sure you've done answers right. I don't want anybody to feel like they're turning in an answer on a homework and not knowing if it's been done correctly. If you want to show it to the TA and be like, did I do this right? They're going to help you out. I want everyone to make sure that they can do that. Now, where's it going to be held? It's going to be held in the Civil and Materials Engineering building. That's CME building. It's going to be in the 3rd floor hallway. So if you step out of the elevator and look left, you'll see this. So it's got a bunch of whiteboards, a bunch of really nice student spaces, charging ports. It's actually a nice space. So go check that out. That's where most of the TA sessions are held. The one exception is that on Monday nights from 5 to 7, that's typically going to be a pretty heavily attended one, I think. That will be held in our classroom unless there's a scheduling conflict. Right now, I think it should be a problem, not a problem. If there is, then we'll find another place, okay? One thing to note is that I myself will always hold a review session on the week of exams, right? So if you had any last question that you needed to make sure that you had a chance to ask me about it, I'll always do it the week of the exam. And 1 week in advance of every test, I'll post a study guide so that, and we're going to cover a lot of stuff in this class, and I know that you can't study for all of that, so I will post a study guide that reduces the amount of things that you need to study for so you can really have, an excellent exam performance. Okay, there are some things that are sort of regular concerns that people have about this class. Sometimes they say, okay, well, some of the material that we cover, it's not in our textbook. For example, we do cover some things about thermodynamics. It's just a few days. It's like 2 or 3 days worth of lectures. So don't worry about that. We will have additional readings and our course notes, like what you're looking at right here. I make all of these course notes available. Okay, so should you be worried? Nope, you don't need to be worried about that. Okay. Some of you, another concern is, some of the people that take this class have seen free energy in their 2nd semester of Gen Chem and others haven't. So should you be worried? No, you shouldn't. We're going to cover that stuff in this class as well. Just the basics, just the most useful parts of it. We're not going to go into great depth from there. And then lastly, we're going to go out of order in this book. Should you be worried? No, don't worry about it. We're going to jump around because we have civil engineers that only take a half semester of this class, and we want to teach them the most important stuff before they jump out. And I think it makes sense to cover things like free energy first anyways, because that's the building block that everything goes on top of when it comes to understanding how materials work in the real world. All right. So something I believe in is called notes with gaps. I've taught this class 6 or 7 times now, and I've found that notes with gaps is a great way to do it. So how this works is I'm going to provide these lecture notes, sort of things like you're looking here. I'm going to provide these ahead of time, and then I'll have gaps in it. So if there's a key equation or something that I'm going to do a drawing to show some sort of principle, I'm going to have a gap there. So the idea is that you can either print these off ahead of time or download them. They'll be PDFs, so do whichever you like. And then during class, you can pay attention by sort of drawing in the equations or writing in things that, if there's something that's not in the notes, you can write that in to pay a little better attention. Realize that these notes are essentially my summaries of each book chapter. As I read through the chapter, I said, okay, that's important, that's important. These are not a substitute, though, for reading the chapter. These are just some of the salient points that I'm going to talk about in class. You should still be doing the reading. In fact, to help emphasize that, we will have reading quizzes using Top Hat. And again, these will be easy things. We mostly vocabulary and stuff, but they're meant to keep you reading. My TAs will be really good about posting the reading schedule at least 1 week in advance. I can tell you roughly what it'll be for the whole semester, but we might get a little bit of behind schedule here and there. So we will be posting those about weekly. Okay. Realize that the notes after class with scribbles will also be posted. So I'm going to be scribbling things, equations and stuff. I'll be writing them on here, and then at the end of each chapter, I'll go ahead and export that with the scribbles. So if you want that format where you're not paying attention and you just download the scribbles at the end, that's okay too. I suggest you pay attention because they've literally done investigations on the brain, and when you're listening, reading, and writing, your brain is just fully engaged. You're gonna remember a lot more than if you don't do that. Okay. Now, a big part of doing this active learning in class where we use Top Hat is that you do have to pay for it. I've tried to buy the cheapest book possible to make up for it, and it's not that expensive. A Top Hat subscription is $4 a month, and you don't have to buy some physical clicker. You can use your phone or your computer, actually. You don't have to have a phone. You can use your laptop or phone or whatever is convenient. If any of you are out there that don't have access to that, let me know. You can even text things in with an old phone, I'm told. If you don't have access to that, come talk to me. If you don't want to do it in front of everybody, come find me in my office hours. We will work something out, okay? Even if it's like a paper copy or something, we can work it out. But I think for the majority of you, this is actually really useful. You can go back and review your answers in the app for different questions. So these are things that I pull on for exams and stuff. So it'll be useful for you, okay? Now there's sort of two well-known facts here. Why am I doing active learning? The first well-known fact is that students don't really like active learning because it's harder. Right? It requires you to be paying attention in class and talking to people and engaged, right? And sometimes you want to show up in class and just be chill, right? I get that. But the other really important thing to note is that there is like this enormous body of evidence that shows that active learning improves learning outcomes. Tons and tons of evidence. So you will learn more. That's why I'm doing it. And it's more work for me, honestly, but it's worth it because you will learn more. Now, how do I get people to actually participate in this? 10% of your grade, no matter which section of the class you're in, 10% of your grade is going to be based on this coming to class and participating, clicking answers in. And again, I'm not going to expect you to get all of them right, so don't sweat it. I think at the end of the semester, if there was something like 200 points possible, getting an A will be only getting like 150 of these or something like that, okay? So it's going to be reasonable. That said, come every day that you can. Do the readings ahead of time, participate in class. And what's great about that is that by doing this, we allow you to work in groups. Bring your calculator to class. We'll actually be doing homework problems and example problems in class very often. And you can work with the people around you. This is a great way to meet new people, find study groups, and you'll learn things better as you're explaining things to people around you. Because sometimes in class you just don't get something, and then you're like thinking, I'm the only one who doesn't get this. But by being able to do these polling exercises, I'll be able to identify if big groups of people are understanding something, and I can re-explain it again. Okay, so be ready for these top pack questions to be starting in class next Wednesday. So that's going to be Wednesday let's see. So the first day of class is a Monday. The next day of class is Wednesday the 21st. So we won't start top hat until August the 28th, okay? August the 28th. That'll be our first real top hat quizzes. But get it ahead of time, and that way we can make sure it's working. You can come by my office, we'll make sure it's working and everything. We'll do some examples in class too, just to see if it's working, but not worth any points yet. Okay, now, if you are taking this student as MSE 2010 or MSE 2165, then you have to take a lab portion of this class, which is gonna be rad. The labs are super, super fun. We do things like blacksmithing. We do really cool stuff. We make molten glass and turn it into stained glass. We do really cool things. We have a cooking one. Danny, my TA, is gonna do I think a science of chocolate this semester. It's gonna be rad. So realize that the labs are super fun. They'll be held almost every week. I think that there's 15 weeks in a semester and we have 10 labs. So, we skip weeks where there's a test. We don't want to overload you with that. We skip weeks on fall break and Thanksgiving break and things like that. But there will still be about 10 of these labs. Realize that we do these to get you exposed to different materials and processing hands-on, but also because you're going to write about them. And that technical writing practice is really great. One of the things that I'm really big on, I'll talk more about this to the lab students in private, is revision. You're going to turn something in. We're going to mark it up with all the flaws in it, and we're going to give you a chance to revise it before we ever assign a grade, and we'll do that on every single one. That's a lot more work for us because we have to grade things twice essentially, but it is so much more valuable because instead of just turning something in and getting feedback and then forgetting it because you just got a low score or whatever, high score, now you're going to actually have to respond to feedback if you want to get a score at all. It's going to make your writing get a lot better. Okay, let's talk about homework. The homework in this class is challenging, and you will need to start early. I'm going to say it again. It's challenging. You're going to need to start early. In college, if you talk to your guidance counselor, any college, they will say this. For every 1 hour of class, you should plan on 2 to 3 hours of study and homework, right? So think about that. If you're taking this as a mechanical engineer, you're taking 3 class hours a week. You should be studying on at least 6 to 9 hours per week. So if that's a different experience than what you've had so far in your college experience or high school, be ready for it, right? Don't overload yourself with other responsibilities. Realize that you will be working pretty hard in this class. And we have homeworks, again, almost every week. It's just like the labs. There's 10 over the course of a 15-week semester. So again, we don't have them on weeks of tests. We don't have them over fall break and stuff like that. But pretty much every other week you will have a test. Now, you'll have a homework, excuse me. So the homeworks in this class, they consist of book problems, right? So in the back of each chapter in the book, there's some helpful, what I would consider sort of plug and chug problems. You know the exact equation to use. You're just plugging in numbers and you're seeing if you can get an answer. That's not as useful to me as the real world. In the real world, you're going to go as engineers and you're going to face real challenges. Your boss or a customer might come with some sort of weird challenge. And you're going to have to apply the concepts that you've learned to solve that problem. And that's what a lot more of the other, what are called PDF or extra questions are on each homework. So I'll have these homeworks posted very soon, but you'll see what I'm talking about. There'll be some from the book, and then I'll have four extra previous test questions. These are questions that actually showed up on some test in the past. I've been teaching this for enough years that I've got lots and lots to pull from, and I write new ones all the time. So what I like about this is that the homework questions, they started out as a test question, but then I made them a little harder. Therefore, by the time that you take a midterm, all the questions should be a little bit easier than what you've done on the homework, right? I do that by design because I want you to be prepared and not be hit with anything out of left field. I will never test you on something that I haven't given you as a homework problem first, right? The concept will be exposed to you as a homework problem before I ever give it to you as a test, okay? I've said it before that, again, if you buy the 2nd or the 4th edition of the book, you should not use the homework questions there because they changed it a little bit. You need to make sure that the homework questions come from the 3rd edition. And again, if you buy the 2nd or the 4th or whatever else, make sure you find the PDF of the scanned homework problems on Canvas, okay? Speaking about homework questions, I think this is uploaded now. Yeah, okay. So this is our top hat page. If you scroll to the very bottom of it, there's these worked example problems, right? So these worked example problems videos here. Chapter by chapter, as we go through different things in this course of the semester, let's say we're on chapter 2, right? And I talk about some concept that wasn't clear to you. What's great is that I've made a couple YouTube videos for some of the hardest problems, right? So as we're explaining interatomic forces, you can just click on this and it will actually start playing the YouTube video of me working through an example problem, right? Which is really great. You can see, a real problem, how do you go about it? And I go through all the gory details. You can stop it, you can slow it down, you can look at something again. It's all there. So check these out. I think these will be a useful resource. Students have been pretty happy about them over the last couple of years that I've introduced them. So for every basically type of homework question that you're going to see in this class, I've done some examples, and they're found on the top hat page down at the bottom of the discussion area. Okay. Okay. When it comes to homework, I would love for you guys to work in groups. That is fantastic. That's how the real world works. You work in groups. That said, the homework that needs to be turned in is individual. It needs to be original work, right? And otherwise is academic misconduct. So if one student is sort of taking notes while you guys all work and then you all photocopy his response and then turn it in, that's cheating, right? Instead, you can all work together, you can talk about something, you can draw it up on the whiteboard, but you all need to write down your own version of it or type it up even better. That's good practice anyways for you. You need to turn that in on your own, okay? There will be no late work accepted. Normally this is going to be due 1 week from when it's assigned. So homeworks will always be due on Wednesdays in this class. So I'll typically have them assigned Wednesday and then due the next Wednesday. That said, you can check out on Canvas, right? And I think your landing page on Canvas is actually assignments. And I've already posted the due dates for all 10 homework assignments on here. Internet's going slow today for some reason. You can see that all 10 homework questions already have their assigned due dates, so you can plan around them. I've also put the dates of the midterms and the final exam. So if you have travel or things, make sure you plan around those now. I'll talk about what to do if it doesn't work, okay? Now, because this is a large class, returning your homework is challenging. It used to be the case that you could just pass the homework around the room and you could pick up your copy from the stack. That's actually not allowed anymore. That's not, there's FERPA requirements that don't allow us to have your, things like your grades exposed to everybody. So because of that, you're going to have to pick up your homeworks during TA hours, right? You're gonna have to actually come and pick up your homework during TA hours because they won't be passed out in class. Now, to make it easier for us, we're gonna arrange these alphabetically. And if you have multiple different family names, different surnames, go ahead and circle the letter of the name where you want it alphabetized, right? So if you've got, several different names, circle the one where you want it to be alphabetized, okay? Of course, we are happy to regrade things. If you think that there's been a mistake in grading, it happens, we're humans, go ahead and let us know. But all we ask is that you let us know within 1 week of when we hand it back to you, right? What we don't want is at the end of the semester, 150 students to say, regrade all my homeworks. Like, we're not gonna do that. So check it out. I'll be posting solutions to all the homework so you can actually compare and see, what went wrong. And if there's a legitimate mistake on our part, we'll fix it. That's no problem for us. Okay. So again, grading will be done on a per student base, on a per class basis. So check out your syllabus for the exact details. So grading will be done on a per section basis. So check out the syllabus for your specific section and you'll see how it breaks down. Our tests were 30% or 35% or 25%. It'll say on your syllabus, okay? Cheating is absolutely not tolerated. We go to great lengths to watch for cheating. Every semester we have to bust people. Let me just say, please don't make me have that conversation with you, with your department chair, and with your dean. It's awful. It's really the worst. So don't do it. It's not worth it. Instead, come get help, right? We have lots and lots of office hours, right? So I'll show you the office hours. Okay, here's what we've got for this class. We have so many office hours. We have 5 wonderful TAs, and I'll introduce them to you in person when I get back after the first 2 days of class where I won't be there. So we have Elias, Danny, Travis, Andrew, and Conrad, and myself all have office hours, right? So we tried to make office hours available in the mornings, in the nights, in the middle of the day, lots of variety. Obviously, you can use the Piazza discussion section on Canvas anytime you want to ask questions. But if you want to be there in person and ask people, that's great, and you can do that as well. So since homeworks are due on Wednesdays, we front-loaded the beginning of the week since even though I'm telling you to start early, I know that some people will wait. So Monday night, that's going to be a really big one, I think. That will be held in, that says in CME, but that's going to be in our classroom probably. I'll fix that. But from 3 to 5 on Monday, on Tuesdays from 8:30 to 10:30, on Tuesdays from 2 to 4. I will hold mine right after Wednesday. Now you're going to turn your homework in right before this. So what I envision this will be is more about concepts and less about homework. But also you can stop by anytime my office door is open. I'm in the Civil and Materials Engineering building, CME, office 314. My door is always open. Just stop by, pop in. I won't care at all. I love talking to students. I've got a giant whiteboard. We'll do lots and lots of problems until you're comfortable. And then Conrad has one, I think it's from 3 to 5 on Fridays, okay? So we have lots and lots of TA support. You can contact them by email if you want. I think Piazza is better because if you have a question, probably somebody else has that same question. And if you post it on Piazza, other students can answer, we can answer, it can turn into a discussion and it'll be better for everybody, okay? Okay, a few things and then we'll wrap this up. First off, who's taking this class? So it's some MSc students, about a quarter of you, a little more now, some civil engineers, and then mostly mechanical engineers, right? Now, what are you gonna learn? Why are you taking this class? And what are our learning objectives, right? So here's the main things that I want you all to take away from this class. There's a reason that they have you take this, even though you're a mechanical engineer. You're like, I'm not a materials, no, why am I doing this? Here's why. It's important for you to understand the relationship between the structure, how we process materials, and their properties, right? So there's different grades of steel, for example, 1010, 4340, right? We'll learn what those things are and how they relate to composition or structure. And then we'll talk about how these things can be processed different way, right? If you heat treat a steel, or if you put it in a corrosive atmosphere, right? Or if you put it in the ocean, right? These are all can be considered processing steps that will influence the final properties. And no matter who you are, if you're an engineer, you'll be surprised. There is always a materials aspect to what you're working on. And so it's important to know these. We're gonna learn, how do you know what material to use for a given application? We'll talk a lot about choosing materials. I've actually got some cool tools to show you this semester. We will explain some of the differences in structure. For example, what's the difference between an ordered material, a crystalline material, right? These two things that are ordered and crystalline versus a glass, which is totally disordered, right? We're going to learn about the role that defects play in predicting material properties or influencing materials properties. We'll talk a lot about sustainability because I'm just passionate about that. We live in a planet where we have 7.5 billion people here and we face huge challenges and we have to consider sustainability as we design engineering solutions to that. We're going to predict material properties. If I give you a given composition, structure, environmental condition, I want you to be able to start getting a feel for predicting different properties, whether that's strength or corrosion rates or whatever else. And lastly, how do we know if a phase is stable? And if it's not stable, how quickly is it going to turn into something else, right? Things transform from one phase to another all the time around us. Some of this vocabulary and stuff we'll be talking more about later on, but that's something we'll be covering. Okay. So if you've heard, when you think about materials, hopefully what you're thinking about is like, well, I've seen materials before. There's materials all around me, right? There's bottles, we've got hard things, we've got soft things, we've got fibers, we've got plates, we've got metals, all these different things. The world of materials science is often broken down into categories. For example, polymers. Polymers, when we think of polymers, we think that they're, in general, and there's exceptions to all these rules, but we think that they're flexible, they're lightweight, they can be easily processed, right? You can melt them and shape them, injection molding into different things, okay? But there's exceptions to those rules, like Kevlar. Kevlar vest, that is not so flexible. It is really crazy strong. It's not super easily processed, right? Lots of cool different exceptions to these rules, right? Then you've got things like ceramics. Now ceramics, when you think of ceramic, you think of something that has a high hardness. It's really hard. It might be really strong. They typically have really high melting points, but they're brittle. Now there's exceptions to all of those rules. There's tough ceramics. There's low melting point ceramics, ice. Right? Ice is a ceramic. It's brittle, it's hard, it's strong, but it melts at really low temperature, right? So there's exceptions to all these rules, which makes it really hard to define all these categories, but they're sort of broad terms that we are used to hearing. There's metals. When we think of metals, we think, okay, these are good conductors of electricity and heat. They tend to be ductile, so you can bend them and shape them, but they're still pretty strong. They don't like shatter and break, right? That's your metals. And again, there's exceptions to all those rules. And then you've got, electronic materials like semiconductors. These typically are characterized by having what's called a band gap, separating the conduction band from the valence band. So we'll talk a lot more about those later on, but you can use these things to make LEDs and lasers and integrated circuits and tons of other things. So we'll talk about those at great length. And then sort of the last class of things is composites. And composites is really like just take any two of the other classes and you smush them together, right? So you could take carbon fibers, which kind of behave like ceramics, and then you put them in an epoxy mold or like a fiberglass. Here you've got glass fibers and you're putting epoxy around it. Voila. Glass, right? Your epoxy plus your glass, two classes of materials, put them together, and you have something that gets the benefit of both of those, right? You can see these in ceramic metal matrix composites. So you got ceramic fibers and metal around them. For example, the Boeing 787, the Dreamliner, 50% of this airplane by weight is composites. These are becoming hugely important. Tons of engineering applications rely on composites because they're just better than individual classes in many cases. So what else is material science, right? Have we covered everything with these sort of different categories? No, there's more. So the question I'd ask is chocolate material, right? Is chocolate a material? Is chocolate something that we can engineer? Yeah, you betcha. So first off, there's a great link if you're interested in learning more and going down a serious YouTube, rabbit hole. There's this awesome series of lectures from Harvard's Science of Cooking that they put on, and there's a great one that talks about tempering of chocolate, right? So I also talk about this. I actually host a materialism podcast if you're interested in learning more. So we actually host a podcast called Materialism where we cover things like this. Like, for example, in our very latest episode, we covered the history of chocolate as an engineering material, right? So you can check this out. I think I'll be building this into some of our assignments because it's just a cool way for me to introduce content to you guys in a new way. But this is available on all different podcast channels, Materialism. Give it a search. I think you'll like it. One of the things we cover in that episode is that you have to temper chocolates. What do I mean by that? Well, there's different phases of matter, meaning the chocolate, the stuff that makes up chocolate, the fat and the sugar, these can come together in lots of different ways, lots of different structures. In fact, there's 6 of them, but only 2 of these are stable. The other 4 will actually degrade over time. They'll break apart and become gross, right? So these things melt at different temperatures. So the 2 that are stable are these that melt at a high temperature, right? So this is temperature on this axis. And you can see that this one, for this type of chocolate, it melts at like 28 degrees. So all these bad phases down here melt at 28 degrees. And the 2 phases that we'd like to form, melt at a higher temperature. So there's this concept in tempering chocolate that if you were to hold the chocolate at that temperature, right around 30 degrees, these 2 phases wouldn't melt, but all of these ones would be melted. And so you would only be left with the 2 phases that you want. So it's this cool engineering problem of getting the phases you want but not the others, right? Now, if you don't get rid of these unstable phases, it can actually be pretty gross. This is what happens. Now, if you don't get rid of these phases, you can watch this YouTube video, but it basically shows how the chocolate and the fat, the sugar and the fats separate over time, and it's pretty gross. And you've probably seen this, right? They call it bloomed chocolate. If you've ever left like a Hershey's Kisses in your car or something, or a chocolate bar in your car, and you came back and it looked like that, that's not mold. That's the sugar separating from the fat, right? That's the sugar and the fat separating, which is, it looks gross. It also has a really gross texture. So I do this every year at the beginning of class. I'm sorry I'm not there on the first day, or I would have you guys be able to try these, but here's these chocolate Lego men that I cast, right? So the top 4 and the bottom 4, these all come from the exact same chocolate, okay? It's dark chocolate because we're not barbarians. We don't need everything to be so disgustingly sweet, right? I make these things and I cast them, but I do these two different ways. These first ones, I do chocolate tempering, which again is holding them at this specific temperature so I get rid of the garbage phases and only keep the good phases, okay? Now the other ones, I melt the whole thing, so all 6 phases are melted, and I just cast it. So when it solidifies, you're gonna get some of these bad phases present, right? And at the moment when I cast these ones actually look a little bit better. They're kind of shiny and nice looking, and these don't look quite as good. But now look what happens if I wait 3 days just in room temperature, right? I leave it on my kitchen counter, and this is how they look. Okay, the tempered chocolate looks wonderful, except for a couple spots where I spilled water on it. That's my bad. And here's the untempered chocolate. These Lego men, they look like they have leprosy, right? Something is very, very wrong with them. So I love this demonstration because it shows you that, material science, it's all around us. It's not just plastics and polymers and ceramics. It's food. It's absolutely everywhere all around us. Okay, so that's all that we're going to cover today in this introduction. I'll make the next video, which will dive into the first chapter, which is chapter 2 in the book, where we'll talk about bonding and how that can relate to different properties of materials.